Hi guys, in the last video we saw how to use input, fprintf and this functions. In this part we will work with matrices and arrays in Matlab. In Matlab you can create an array by enclosing a sequence of elements within square brackets. So this creates an array. We can separate the elements with either a comma or a space. Now, while creating a matrix that has multiple rows, we separate the rows with semicolons, and so this creates a matrix. Now, there are arrays are given sometimes given special names based on their dimensions. So here, the first one is called a scalar. A scalar is a single element array. Next, we have a row vector. A row vector is a single row array. A row vector can have one row and multiple columns, and this is a column vector which has one column and multiple rows. Now, the term matrix generally refers to an array with two or more non-singular dimensions, and the term array is a general term for all these data types. Now, arrays may be created with built-in functions in MATLAB and modified with mathematical operations. You can use the colon operator or the linspace function to create vectors. Both methods produce evenly spaced raw vectors, but one should be used in different situations. Now, the colon operator is used when we know the spacing between elements. That is when the spacing dx is known, and we use the linspace function when the number of points is specified. That is when we know the number of elements between the initial value and the final value of a vector. So vectors may be created using the colon operator, and this is the syntax for creating vectors using colon operator. We have the start value colon, the spacing or the increment colon, the limit value or the end value of the vector. So when I run this, see here, uh, the first command creates a vector that starts at 1 and ends at it was supposed to end at 10, but here it ends at 9, since the elements are spaced by 2. Here, uh, the create a vector that with spacing 1, you can omit the increment syntax since the default spacing in MATLAB is 1. So here we omitted the increment syntax. So 1 colon 5 will give me the vector 1 2 3 4 5 with the starting element 1 and the ending element 5, with each element incrementing by a value of 1. And here at last this creates a vector, this command creates a vector that starts at 1 and ends at 16, and the elements are separated by 5. So if the endpoints are not separated by integer number of spacings, the vector will be cut off at the element closest to but not exceeding the endpoint. We had we saw this in the first command and the last command, wherein we the last element of the first command was 9, not 10, and here the last element was 16, not 18, since since the last element after jumping the specified number of spacings is 16 and 9 in these cases. So that was all about colon operator. Next, we have the linspace function. The linspace function is useful for when you want to guarantee that a vector has exactly n elements and contains both the start and end points. So here is an example. You see here, this command creates a vector that starts at 1 and ends at 10, and it contains 4 elements. So remember, the colon operator is to be used when the specific spacing is specified, and the linspace function is to be used when the number of points is specified. Now we have the transpose operator. The transpose operator um, returns us the transpose of a matrix. That is, it swaps and arrays rows and column values. So if I run this code snippet here I can see my original um, array A, and this is my transposed array wherein the row elements and column elements are interchanged. Now, let's look at some important matrix operations. First of all, we have matrix addition and subtractions. You can add matrices, you can perform addition and subtraction of matrices of same size using the plus and minus operations as shown here. Now, you can multiply matrices using the star operator. Remember that to perform uh, matrix multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So here in this case, both A and B, if you look at the workspace, both A and B both are 3 by 3 matrices, so we can multiply them together in any way. But M1 is a 2 by 3 matrix, and M2 is a 3 by 3 matrix. So uh, I can perform M1 star M2 but not M2 star M1, since the number of columns of M2 is not equal to the number of rows in M1. So Matlab will give an error while doing M2 while finding MB, but we can find MA and M underscore MULT, since the number of columns in the first matrix in both those cases is equal to the number of elements, the number of rows in the second matrix. Now, if you want to perform element-wise operations, if you want to perform operations on corresponding elements of two matrices, just add a dot symbol before the operator. So here A dot star B will multiply each element of A with the each element in matrix A with the corresponding element in matrix B. Similarly, we have the dot dot backslash operator to perform element wise division, and we dot hat 2 operator returns the square of each element in matrix A. Now uh, remember that MATLAB has several functions that we can use to create arrays. For example, an array of all zeros or an array of all ones. Now, the syntax for these functions all have the same basic structure, in that you must specify the number of rows and columns of the array. Now, let's learn these functions by going through these questions here. So, to create a zero matrix, we have the zeros function. So to create a 3 by 3 matrix with each element 0, we just need to type zeros with a 3 inside the bracket. So this creates uh, a 3 by 3 matrix with each element equal to 0. Next, to create a 2 by 5 matrix, we have zeros 2 comma 5. This creates a 2 by 5 matrix with each element equal to 0. Next, to create a 3 by 4 matrix with each element 1, we have the ones function. So ones 3 4 will create a 3 by 4 matrix with each element equal to 1. Now, to create a 3 by 4 matrix with each element equal to 7, in MATLAB you can use the ones function multiplied by 7. So if when I type ones 3 comma 4 star 7, this will give me this will give me a matrix with each element equal to 7. Now To create identity function, identity matrices, we have the I function. So I3 will give me an identity matrix of order 3. Now we have the random, and randi functions in Matlab to create vectors or matrices of random numbers. So the rand function, or the rand function, creates a matrix of uniformly distributed random numbers between 0 and 1. It can create arrays of various dimensions filled with random numbers. So to create a 100 by 1 vector of uniformly distributed random numbers, just type in uh, rand 100. So this will give me a 100 by 1 vector of uniformly distributed random numbers. Now to create a 100 by 1 vector of normally distributed random numbers, we have the rand n function. So now the rand n function generates normally distributed random numbers with mean 0 and standard deviation 1. So this will return to me a 100 by 1 vector of normally distributed random numbers with a mean 0 and standard deviation 1. Now, we have the randi function that creates a matrix of uniformly distributed random integers. So we can either provide the maximum value as the first input, followed by the size of the array, or we can provide the function. Now, this is the actual syntax. So now, and we can provide the function with the minimum value and maximum value as an array, followed by the size of the desired array. So to create a 100 by 1 vector of uniformly distributed random integers with a maximum value of 10, I can type rand I 10, then the size of the matrix 101. So this will give me a 100 by 1 vector of uniformly distributed random integers with a maximum value of 10. So here if you look at this vector, you can see the maximum value is 10. No element exceeds the value 10 in this vector. Now, to create a 10 by 1 vector of uniformly distributed random integers between minus 3 and 3, I just need to write rand I with my first argument, the array minus 3 3, then followed by the size of the vector that all the matrix I am going to create. So in this case, it's a 10 by 1 vector. So this command will create a 10 by 1 vector wherein the minimum value of an element is minus 3, and minimum value of the elements is minus 3, and the maximum value of the elements in the vector is 3. So if you look here, the maximum value here is 3, and the minimum value will be minus 3. Now the uniformly distributed random integers generated by rand I by default lie between 1 and the specified maximum value by default. Now we just saw that we can specify the interval over which the random integers are distributed using this syntax here. Now, so this code will generate random integers between minimum value and maximum value. Now, the uniformly distributed random numbers generated by rand function, which we had seen here. So the um, the rand function, the numbers generated by the rand function generally lie between 0 and 1 by default. Now the rand function doesn't allow you to specify the interval over which the numbers are distributed, uh, like in the case of rand I function. So if you want uniformly distributed numbers between two values, a and b, you can compute that using, you can create the vector using this command, x is equal to a plus b minus a star rand mn. So to create create a 50 by 1 vector of uniformly distributed random numbers between -1 and 1, I just need to type a in this case, -1 plus uh, b minus a, uh, 1 minus minus 1 is 2 star rand 50 1. So this will create a 50 by 1 vector of uniformly distributed random numbers that lie between -1 and 1. And similarly, normally distributed random numbers generated by RANDN function will have a mean of 0 and a standard deviation of 1 by default. So if you want normally distributed numbers with a mean, say capital M, and standard deviation SD, you can you can make the vector using the command m plus sd star randn m comma n. So to create a 50 by 1 vector of normally distributed random numbers with mean 100 and standard deviation 5, we just need to type 100 plus the standard deviation, which is 5, star uh, randn, the size of the vector, which is 50 by 1. So this will give me a 50 by 1 vector of normally distributed random numbers with mean 100 and standard deviation 5. So this was all about creating vectors and matrices in Matlab. Now, we had seen concatenation of strings using square brackets in the last video. You can also concatenate two matrices in Matlab. So here too, the square brackets are the concatenation operators. So if I run this code snippet here, so so okay, let me run this again. So here too, the square brackets are the concatenation operators. They glue together the things that you put in them. So here we have a randomly generated matrix M1 and another matrix M2. Now, to combine two matrices vertically, um, we just need to add a semicolon between them, and for side by side combination, just separate them with a comma after putting them in square brackets. So uh, this command will give me the horizontal combination of m1 and m2. You can see that here in this newly generated matrix, and similarly for vertical combination, just separate add a semicolon between the two matrix names. So this is all about vector concatenation, or matrix concatenation in MATLAB. So in this video, we have covered essential array and matrix operations in MATLAB, including creation, modification, and basic arithmetic. Stay tuned for the next video where we will delve into indexing and accessing elements within arrays. Thanks for watching. See you guys in the next video.